All right, in this video, I'm going to cover the quadratic inequalities in section 3.1, and we'll see a couple of objectives in 3.2. So first one, we'll see quadratic inequality. So we want to solve the quadratic inequalities, but yeah, how do we solve the problems? So I'm gonna study two methods. The first one, as you can see, the graphical method. The second one is a test point method. So those two methods are the similar, but the only different thing is this graphical method. We figure out this, the solution interval, solution set by reading the graph of quadratic functions. But this test point method, we wanna, instead of drawing the graph of quadratic function, we just choose a random point, and then we figure out the sign of those points. They are called test point. So we'll see later. First one, graphical method. So there are 4 steps. First step is get 0 on one side, and the second step, find all roots, and then step 3, graph, and step 4, read the solution set to the inequality. So let's take a the look at these steps in detail by solving one example. Okay. All right. So now, so think about this. See, graphical method. Okay. So in graphical method, it's the example. This is example 7 textbook. Okay. 2x squared minus 4x minus 9 is less than 0. Okay. So step 1 is to get 0 on one side, but we already got 0, right? I mean, the problems they give us inequality having 0 on the right hand side. But if you get certain terms on the right hand side, you have to move those terms to the left hand side. Okay. So the step 2 is to find or root to the quadratic polynomial. It means that we're going to consider that quadratic polynomial as quadratic the equations setting equals 0, and then we solve that quadratic equation. Okay, but the what does that mean? Root is the number making the polynomial to be 0. Okay, so root is is nothing but the solution of quadratic equation. Okay, so the step 1 get 0 okay, on one side. Okay, and step 2 we find all roots. Okay, so how can I find all roots? Yeah, so we said let me use the quadratic quadratic formula. Okay, so we use this one. X is equal to negative b plus minus square root of b squared minus 4ac over 2a. Okay, so if you just by the way, if you're confused between the root and solution, yeah, then you just set 2x squared minus 4x minus 9 equals 0. Okay, set, you know, the equal quadratic equation, set adding equal sign is 0 with this, and solve that quadratic equation. That should be okay. Okay, so now the a is in this case a is a 2, right? And then b is negative 4, and then c is negative 9. Okay, so now then what are we going to do? Yeah, we plug them this numbers into the formula, quadratic formula, right? So then x is equal to 4, okay, plus minus square root b square root, which is 16, minus 4 times a times c. So we got the plus, right? 72 over 2a, which is 4. Okay, so this is going to be 1 plus, plus minus, and then what, 16 plus 72 is what, 88, right? 88 is 2 times the square root of what, 22, right? Okay, over 4. Okay, so yeah, I just separate that fraction to two the fractions. Okay, 4 over 4 plus minus square root of the 88 over 4. Okay, so the 4 over 4 is nothing but 1, right? And then you got this. Okay, so that this is equal to 1 plus minus, and then square root of 22 over 4. Okay, so now the in a view of, I mean, see, what are they? These are root, right? Or we can say these are equal solutions of quadratic polynomial, right? 2x squared minus 4x minus 9 equals 0, right? We can say that, right? So now, keep in mind this, but okay, yeah, let me do move to step 3. Now just keep in mind this, okay? So these are solutions of quadratic polynomial, quadratic equations, or we can say roots to the quadratic polynomial 2x squared minus 4x minus 9. Okay. Now step 3 is graph the corresponding quadratic function. So what does that mean, quadratic function? So quadratic function means the quadratic, I mean, corresponding. Let's see. So corresponding quadratic function means the quadratic function whose equation is the equal to the the quadratic polynomial in the quadratic equation. Okay, so we're gonna view now in step 3. We're gonna view this one as the definition of function. Okay, so what that means. So f of x, we said f of x is 2x squared minus 4x minus 9. So now we see that we're gonna view this guy, the left-hand side, the quadratic inequality, as the definition of function. Okay. So now then we plot the graph of this one. So how can you plot the graph? Yeah, we use the we're gonna figure out the what if this guy graph of this guy's probably upward or downward, and then the y-intercept. Okay, you don't have to find a vertex. Okay, you don't have to figure out axis symmetry, but what we need to figure out is at what point, what x value that graph pass the x axis. Okay, but you see, first one, let's see. You see the a right here? This is a, right? Leading coefficient. If leading coefficient is greater than 0, then the graph of f of x quadratic function must be parabola opens up, right? And then you see that the back to the step 2 solution, the quadratic equation, solution of quadratic equation is this, which means that there are 2 solutions of quadratic equations. But last time I told you the number of, these solutions is nothing but what? X coordinate of the x axis of the corresponding quadratic function. Let me tell you again, that these solutions means what? The x coordinate of the x axis of the corresponding quadratic function. So since this equation, quadratic equation, has 2 solutions, it means that what? The graph of this guy, f of x, must pass the x-axis twice. So that graph must be what? Like this. Okay, like that. So here's a one. Let's say I think this is Give me a second. 1 plus. Let's say here's a 1 plus square root of 22. Okay, it should be 2, right? It's typo, right? Sorry, 2. And then here's 1 minus. me see. Maybe right here. Okay, it's not correct, but let's say like this. Graph is must be like this because the a is greater than 0, so it means the parabola opens up, right? Like this. Okay, like this. Okay, and then from the graph, we're gonna the what? So as you can see that these roots determine the what x intercept, right? And then step 4, we're gonna read the solution set to the inequality from the graph of the parabola. Okay. So back to here. So now see, this is what in a step 3. We did view this one as definition of f of x. So solving that inequality is nothing but what? We're solving the we want to solve the f of x is less than 0. But f of x means the y value, right? So we want to find out the interval on the x-axis where y value is less than 0, which is here, right? From the what? From 1 minus square root 22 over 2 to what? 1 plus square root 2 to 2. So it's open, right? Because the inequality doesn't contain the what? The equal sign. So it should be open, right? So from here to here, since graph below the x-axis, so f of x must be less than 0. So the answer is what? The 1 minus square root 22 over 2, comma, 1 plus square root 22 over 2. Okay. If you want to figure out whether or not, this f of x, graph of f of x cross the x-axis without looking at the, number of solutions in corresponding quadratic equation, you just figure out the h, which is x-coordinate vertex. So here vertex h is what? Negative b over 2a, right? Which is a negative 4 over 4, which is a 1, right? Is a 1. Okay. So now the you see, and then now we could k gonna be what? I need more space. Let me move to the next page. So we got h, right? Is a 1, and then k is f of h, which is f of 1. This is a 2 minus 4 minus 9, which is negative 11, right? So the vertex is going to be 1 comma negative 11. Here's a 1, and then negative 11. Okay, and then since a is 2, which is greater than 0, so graph must be like this. So as you can see that the parabola cross x-axis twice. It means that what? You see that? It means that this is the what? 1 minus square root 22 over 2, and then this is 1 plus square root 22 over 2. Okay. So anyway, so keep in mind this step. Okay, step 1, get 0 on one side. Step 2, find all roots, and then step 3, grab the quadratic function, corresponding quadratic function. Step 4, read the solution set from the graph. Okay. So what if a problem is not in the quadratic inequality? In the inequality is not like this, less than, but greater than or equals. They want to find out what the interval on the x-axis where f of x, which means y, is greater than or equals 0, which is what? From here to here. From negative infinity to the 1 minus square root 22 over 2, the closing number because there's equal sign. And then from 1 plus square root 22 over 2 to infinity. Okay. So now let's move to the next method. Okay. The test point method. Okay, so let's see. Okay, test point method for solving a quadratic inequality does not involve the graph of the quadratic function. I told you right at the beginning of class. So instead of not like the graphical method, we don't have to plot the graph of quadratic function in test point method. Instead of that, we're gonna pick the test point randomly for each subinterval identified by the root of the corresponding quadratic polynomial. What that means? So in here you can see that step 1, step 2, And then step 1, step 2 are exactly the same as step 1 and step 2 in graphical method. Okay, get 0 on one side, find all roots. And step 3, instead of graphing, we're going to select test point in each interval determined by the root. And then step 4, evaluate quadratic function at each test point. And then step 5, determine the solution set from the sign of the function at the test point. Yeah, let me explain this one by solving the problems. Okay. So second, see. All right. So let's think about this. X squared, okay, minus 2x minus 4 is less than 0. Okay, actually, this is try these problems. Okay, so now what are you gonna do? Step 1 is get 0 on one side. Okay, get 0 on one side. Okay, let's skip it. Okay, because we got 0 on one side, right? Step 2, yeah, find all roots. Okay. So now, yeah, we solve what the equation x squared minus 2x minus 4 equals 0. Okay. Yeah, let me use the quadratic formula. Okay, normally we use this. So x is equal to minus b plus minus square root b squared minus 4ac over 2a. Okay. So now then, well, this is equal to minus b must be 2, right? The plus minus square root of b squared is what? 4. Okay, and the minus 4 times a times c. Okay, so which is 16 over 2a, which is 2. That is equal to 1 plus minus square root of 20 over 2, okay? So now that is equal to 1 plus minus, well, square root 2 times square root 5 over 2, which is 1 plus minus square root 5, right? Okay. So now, as you can see that, give me a second. Let me double check if this is the right, okay? I just want to make sure that I got the right answer, right solutions, okay? So, all right, so I think it's right. Okay, so it means that what we got two solutions. It means that the graph of the quadratic function, I mean, considering this one as, considering, f of x, this one as a definition of a quadratic function, which is x squared minus 2x minus 4, okay, right? Then that function must have the what 2x intercept. So graph parabola, should pass the x-axis twice, right? Okay, but I'm not gonna graph the f of x. Okay, in step 3, we just draw the number line. Okay, it's negative infinity to infinity. Okay, and then I'm gonna mark the that root. Okay, 1 plus minus square root 5. Okay, so maybe here is a 1 minus square root 5, and then here is 1 plus square root 5. Okay, so now then this number line what has been this the what divided by 3 subinterval, right? There's interval subinterval 1, subinterval 2, subinterval 3. And then we know that what considering this number line as x-axis, the graph of f of x must be like this, right? Must be like this. Okay. But anyway, so yeah, I told you what, in test point method, we don't plot the graph of f of x, but the thing is this: we draw the number line and then the mark the what the solutions of the quadratic polynomial, what we got in step 2, and then we divide the number line. Then the number line will be, divided by 3 subnumbers. Okay, but depending on the number of solutions, maybe number line will be divided by 2, or number line will not be divided by, or maybe divided by 3 like this. Okay, that total depends on the number of solutions of the quadratic polynomial. Or we can say that total depends on what number of the x-intercept of the quadratic function. Okay, now step 3. So now we pick the test point. Okay, so I'll pick the test point for each subinterval. Okay, so right here, this one, any test point should be fine. We gonna, in step 3, we're gonna pick the test point for each subintervals. So here I think 1 minus square 5, I think what negative 1 point something. So let me pick the negative 3. Okay, and then definitely 0 must be between the 1 minus square 5 and 1 plus square 5. Okay, so I picked the 0 for the second subinterval. And third subinterval, maybe I pick the 5. Okay, so now what I'm going to do, step 4, evaluate the quadratic function at each test point. Okay, so okay, step 3 is selected, by the way. Oops, a test point. Okay, test point for each in each subinterval. Okay, step 4, evaluate the quadratic function. Okay, at each test point. Okay, so now then f of negative 3, and then f of 0, and then f of 5. Okay, you don't have to by hand. Okay, just use calculator. So but then you're gonna get a number. Okay, so for example, f of negative 3 gonna be what? Negative 3 squared. Okay, so and then minus 2 times negative 3. Okay, and then minus 4. So we got 11, right? Okay, so you're gonna get the number right there. It should be negative 4, right? By the way, this is 5. I'm using a number. So the goal is not to figure out the these numbers. Okay, the goal is to figure out sign of a function at each test point. Let me tell you. Okay, so the in step 4 and actually step 5 and step 4 and step 5, the goal is to figure out the sign of function f at each test point. Okay, so this is positive and this is negative. I think f of 5, I'm sure the f of 5 must be positive. Okay, so now we need to do, and then step 5, so we determine the solution set for the sign of the function at the test point. It means this: if f of negative the what sign of function f at test point is positive, it means that what now in the negative 3, every single number in that subinterval, the what their function evaluation of function must be positive. So it means that f of x is greater than 0. So right here in that interval from negative infinity to the 1 minus square 5, the f of x is greater than 0. Okay, and then what from between from the 1 minus negative 1 minus square 5 and 1 plus square 5, from here to here, the f of x is what? Less than 0. Because f of 0 is less than 0, it means that not only 0, but also every single number x value between 1 minus square 5 and 1 plus square 5, their function value must be what? Less than 0. Okay, because we what we have chosen negative 305 randomly. Okay, so now the third subinterval 1 plus square 5 to the infinity, the f of x what is greater than 0. Okay, so actually the sign, this sign represent what represent the what the sign of function f, not only just test point, but also all of the x value in that subinterval. Okay, so now what back to the problems, we're gonna solve the what this inequality, right? But x squared minus 2x minus 4 is actually what? The definition of f of x. So solving that inequality is nothing but what? Solving that inequality, f of x is less than 0. Then what? This one, right? You see? F of x is, what subinterval f of x is less than 0. And what subinterval? The what? Which subinterval what? To satisfy the inequality. That interval, right? So the answer is what? 1 minus square root 5 to 1 plus square root 5. Okay. So that's the graphical method, and I mean this is test point method. Okay, so I covered the graphical method and test point method. Okay, so the please look at the examples in the textbook and with the solutions. Okay, to review. Okay, so second. In the next video, I'm going to cover the half of the 3.2. Okay.